Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Seer by Shintaro Fushida Hardy. And here are the rules. Chaos construction. Divide the grid into regions, each consisting of orthogonally connected cells, and fill each row, column, and region with the digits 1 to 9 once each. So orthogonally connected just means that they have to be sharing an edge with another cell in the region. With another cell which connects orthogonally to the rest of the cells in the region. So this would be a valid orthogonally connected region. But if we removed one from here and moved it here, this would not be valid, right? Because actually, the first one's not valid because that is valid. That's 9. Okay, but if we removed that cell and added here, the problem is this is not orthogonally connected to the rest of the region. So this is not a valid region here. And obviously the regions also have to be of 9 cells in size also. And we are constructing this as we try to figure out the puzzle. Sightline X sums. Clues around the grid are the sum of the first X digits in the corresponding row or column, where X is the first seen digit. Further, X is the number of cells belonging to the same region seen by the clue, where region boundaries block vision. Okay, so sightline X sums. So clues around the digits, which is SE, ER, EE, SS, a question mark, EE, and SS. They are the sum of the first X digits in the corresponding row or column where X is the first seen digit. So this is typical X sums here. So basically, if this were a 5, that would mean the first 5 digits would add up to whatever S and E are, as S being the tens digit and E being the ones digit. So the first 5 digits could be like, I don't know, 24 or whatever. And so then if the S is a 2 and the E is a 4, this would then have to mean that the first 5 digits add up to 24. And that's how X sums work. In addition, X is the number of cells belonging to the same region seen by the clue, where region boundaries block vision. So in addition, if you had a 5 here, that would mean this boundary then has to be 5 in length. Or sorry, this region specifically has to be the same region, and it's specifically blocked by this. Oops. It would be blocked here, right? So this would be a different region than here. So this would be a different region than this. So this 5 does double duty, as in it says the first X digits sum to whatever S and E is, S being the tens digit and E being the ones digit. And it also says the first 5 cells must be in the same region from E, from this SE clue. Oh. And each digit, S, E, and R, represents a different digit from 0 to 9. And 2 letter clues are interpreted as a 2-digit number, right? That's what I was assuming. So basically, right. So each digit can be S and E, S, E, and R can all be from 0 to 9. So remember that. and represent, and they have to be a different digit from each other. So S is not the same as E, which is not the same as R, but they are the same as each other, obviously. S is the same as S, E is the same as E. And two-letter clues are interpreted as two-digit numbers. So again, the SE in this situation, S would be considered the tens digit and the E would be considered the ones digit. In this ER, the E would be considered the tens digit and the R would be considered the ones digit. With this EE, you would have E as a ones digit and E as a tens digit and then E as a one digit. A question mark clue can be any number, not necessarily a single digit. So therefore, this question mark can be anywhere from, it could be any number, period. It could be that includes anything that's two digits. It could be negative digits technically, but obviously not for the X sum clue. So therefore, it can't be negative. But basically any number essentially, and they don't have to be the same. So this question mark is not the same as this question mark, obviously, because question marks are essentially they could be anything. That's typically from programming notation. Anyways, though actually question mark specifically would be one digit, but we use question mark. Okay, never mind. It's not for programming. It's just basically a convention that we normally have. Is that question mark can be any number, and it's not specified, and it's not the same as other question marks. And the final rule is Nabner. Digits along a gold line belongs to a set of pairwise non-consecutive digits. All that really means is that you can never have a digit on the Nabner line which is consecutive or repeats normally. I'm pretty sure, well, okay, this is chaos construction, so obviously you can't have repeats on any of these Nabner lines. Normally they say that, but since it's already included in the chaos construction rules, I guess that's why he didn't include that. So Nabner lines cannot have repeats normally, or they cannot have consecutive digits on the Nabner line. So therefore, if there was, say, a 2, well, not a gray, a 2 on this Nabner line, you could not have a 1 or a 3 also on this Nabner line, because 1 and 3 are consecutive with 2. And again, any two pairs on the Nabner line cannot be consecutive with each other. So that's another way of stating the rules. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so S and E can never be 0. Because we have an SS as a clue and an EE as a clue. And 0 is never an X sum, right? Because you always have at least a digit 1 in that X sum. So S and E cannot be 0. So they have to be 1 through 9. R still could be 0, actually. So we don't know about R. So R could be 0 through 9. But S and E cannot be 0. So therefore, it has to be at least 11 in the SS and the EE. It has to be at least 10 or 20. Oh, we also know S and E have to be 1 through 4. Because S and E also acts as a tens digit for a clue. And an X sum clue can never be greater than 45. Excuse me. Therefore, S and E both have to be 1 through 4. R could be 0 through 9. So this is either 11, 22, 33, or 44. This is 11, 22, 33, or 44. Same here, same here. Well, okay, so S cannot be 4, because if S is 4, that would mean this is 44, which means it would require this to be 8, and would have to have 8 digits count for the x sum. And this would have to be 8, which would be 8 digits counting for the x sum. But that's not possible because then you would have an 8 here and an 8 here. It could potentially be 33. So S is either 1, 2, or 3. As S is either 1, 2, or 3. So we're going to make this the possible digits for S. E can be 1, 2, 3, 4, and R can be 0 through 9. But we don't know. The problem with E being 44 is that these also, again, they act as X sum, but they also act as the same region. So therefore, if this is 8 and this is 8, they have to be part of the same region, but that's already greater than 9 cells in that region, right? So that's not possible. So E cannot be 4 either. Can E be 3 is the question, right? If E is 3, so that would be 33. It would have to be at least 5. And it could be 5, right? So So this EE can never be 6. Because, well, can it be 4 with that, essentially? Oh, it's possible to be 6. What can this be, essentially, SS? SS 33 requires at most 7 digits. And it could be as little as 5, right? If you have 5 digits adding up to 33 with a 5, you would have to have, I think, what? The other digits would have to add up to 28. So it would have to be 4, 7, 8, and 9 to add up with 5 digits. But that does add up to 33. 33. It could be 11 too. So 11 to 33 has to have then 2 through 7 cells as the X sum clue. So this is 2 through 7, this is 2 through 7. This is 2 through 7, and this is 2 through 7. Well, if this were 7, this could be 2, so that would work. If this is 7, this could be 2, that could work. Let's remove that because that's kind of confusing me. 1, 2, 3, 1, 2, 3, 0, or 0 to 9. This would have to be at least 12. So this could not be 2. So this would be 3 through 7. It cannot be anything more than 32, though. So it could still be 7, but we don't know. And the question marks could be anything. Okay, this is confusing there, too. But this has to be at least 10. So this is, and it could be up to 39. So this could be actually up to 8. This is 2 through 8. This also is 2 through 8. Actually, yes, this is 2 through 8. Cannot be 1. If this were a 7, could this ever be 2? Well, if this is 7, it has to be at least 33. It has to be 33 specifically. So then this would be 33, which would require it to have 5 digits. So this would be 7. Could it be 3? No, because it would have to specifically be 5. So that's not possible. Because then this region would be at least 11. So this can't be 7. If this were 6, well, the thing is about 6 is 6 has to add up to also 33, right? You cannot have 6 digits adding up to 22 because you would also require 6 with those 6 digits. Well, 6, 5, 4, 3, 2, 1 adds up to 21. 6, 7, 4, 3, 2, 1 adds up to 23. And therefore, this can never be 22 if this was a 6. So if this is 6, this again would have to be 33 to add up to. And therefore, this would be 33 adding up to. So it's at minimum 5, which would mean this region is a size 10. So this can never be 6. So this has to be 2 through 5 then. This, though, the SS does not have to follow that rule. So EE still could actually be 33. Um, hmm. Um, let's see. So far, okay. What else do we know? So that's just EE. This could be 7. And then this would have to be 2 or 3. If this is 7, it adds up to 33. So this would have to be 5, 6, or 7. Obviously, it couldn't be 7, but it could be 5 or... It would have to specifically be 5 then. Oh, but that doesn't work. So if this is 7 adding up to 33, and the 7 always... A 7 x sum would always have to add up to 33 for a double S. A double letter clue. It would always have to add up to 33 because it can never add up to 22 because the first 7 digits add up to 28. So if it's 6 or 7, it always is adding up to 33. So if this is 7, then that would mean this would have to be specifically 5 because it cannot be 6 because if it's 6, then these two would have to add up to 12 and therefore would be 6 and 6. But the problem is if this is 5, similarly, this would have to add up to 12, but it would have to be 5 and 7. But we already have a 7 here. So this can never be a 7 then. Because if it were 7, it would have to add up to 33, and therefore these two digits would have to add up to 12. And then 5 and 6 are eliminated from this possibility. And this digit has to be a 5 or a 6 then in that case. What else do we know? Can it be 6 is the question. Well, we know it's at least 2, so it would have to go that way. That means these three digits would have to add up to 12, which is possible with 5 or 7. Hmm. That seems fine as possibilities. Hmm. Can it be 1 1 and 2 2 is kind of the question, right? So the question marks don't help us at all with X sum. They must specifically be sightline. Um, so basically saying that the first X digits are essentially in the same region. Huh. If there's an 11, interestingly enough, what do the digits have to be? They have to be either 2, which is 2, 9 together, or it's 3, right? Because if you had a 4 trying to add up to 11, the problem is 4 digits adding up to 11 can only be specifically 1, 2, 3, and 5. So therefore, the 4 doesn't work, and obviously anything higher than that cannot add up to 11. So if you have one of the E or S as a 1 or as a 1, then they both have to be 2 and 3 specifically. So the other digit cannot be a 2 or a 3, but they could be a 4. So 22 works fine there. So if one of these is a 1, it has to be 2 or 3. Uh, hmm. What else do we have here? Can this actually ever be 8? If this is 8, we know this is at least 3. So this is 1, 2, 3, 4, 5, 6, 7, 8. But the problem is this would be 9 and 10 then. So therefore this region would have to be 10. So this cannot be 8. Oh, okay. So actually we should probably start coloring these. This, but the problem is these could actually be the same region. That's the thing. Well, we know this has to be at least 3. Because this is at least 12, which 2 cannot be with another digit. Uh, yeah, this is either 12, 21, 13, 31, 23, or 32. Hmm. Hmm. Um. Hmm. Well, 2 and 3 couldn't add up to 22 anyways, right? Hmm. Right, so if you have EE or SS as 22. Oh, that's interesting. So say SS was 22 then. If SS is 22, it cannot be 2 or 3 adding up to that because 2 digits can't add up to 22. 3 digits can't add up to 22 with a 3 in one of those 3 digits. So it would have to be 4 or 5, and it could not be 6. So let's say EE was 22. This would then have to be 2, 4, 5. Could you ever have 6 being 33 then in that case? This, because it could not be 4 or 5. It would have to be 6 if it's 33, which means it connects to here. And this could be 4, so then this would be 4. And this would have to be a region. Ah, that doesn't work though. Because this would have to add up to 22. So then this would be 18. And this would have to add up to 33. And 33 plus 18 is 51, which is not 45, which is what the digits 1 through 9 would add up to. So this is not possible. So if this is 22, then this has to be 11. That's interesting. Huh. So if EE is 22, then this has to be 11. Because it can never be 4 and 5 with this 4 or 5. And it tries to be 6, but then this would have to be specifically 4 to have 9 digits in the region, and then but the digits would add up to 51. So that is actually, so if EE is 22, then this has to be, like, this cannot be a 6. It has to be 11 with 2 or 3. Can this ever be 6 is the question. I guess so, right? If this is 6, then this would, okay, so this is 6, we assume. This has to be at least 2. So you have 6 digits adding up to 33, obviously. This then would have to be 5 or 7. So this can't be 6. This can't be 5. It can't be 7. We can't have 4, because then that would add up to 22. And again, we would have the same problem. So this would have to be 2 or 3 adding up to 11. So this amount would be 33. It could be 2 or 3 that way. So then this would be a separate region. This would have to be 5 or 7. This one then be 2 or 3. So this would be 11 also. Interesting. This is feasible though. This adds up to 12 because this adds up to 33. If it's 7, it has to specifically be 1 and 4 here. And therefore, this would be 7. Well, I don't know. So this would be 33. This would be 11 minus 2 or 3. Well, okay, this can't be 2 and 9 then. If this were 2 and this was 9, well, where is the 9 in column 1? It would have to be in one of these 3 cells. But the problem is that to add up to 33 with 6 digits and a 2 and a 6, you almost assuredly have to have a 9. Because you can't have... The only way the 9 could not be in one of these 6 adding up to 33 is if this is 912, which is not possible. So this can't be 2. This would have to be 3, which would force this to be another digit. These 3 digits would have to add up to 12. These digits would have to add to 11. So that, okay, so this is 33. This must be 8 then. So this is 41. Right? For these 8 digits, this is 33. This is 11 minus 3, which is 8. So that would be 41. So the last remaining digit in this region would have to be 4. So this can't be 4 here. This could potentially be 1, 7. It couldn't be 4 anyways. It's 1, 7. It cannot be 2, 6 because the 6 is here. So this would have to be 1, 7. So then this would have to be 1, 7, 4. Which is possible, actually. Dang it. That's not what I was hoping for. Yeah, it's not what I was hoping for. Because this could actually be 1, 4, and 7 here, which would be valid. Then this would be 1. This would have to be... Yeah, 1 and 7 would have to be here. So then this would have to be 1, 7, and 4 specifically. So this would be 1, this would be 7, this would be 4. This would be 33 adding up to that. We know it's 1, so therefore this would be specifically these. But that doesn't work. The reason why this doesn't work, so this is 1, which means this cannot be part of any other region here, so it must connect to this region. So this must be part of the region, which makes that 7. And this is all part of a Nabner line. The problem is, basically, what are the 2 remaining digits in this cell, which must be in this region, specifically? Well, it has to add up to 12, because again, this adds up to 33 in that case, if this is 6. Well, if that's 6 and this adds up to 33, this then can never have a 1. So 1 has to be in this region, which eliminates that possibility for being a 1. And this can't be 4 because this is consecutive with a 3. So this is the only way this could work as this being a 6. So we now know... Okay, that's interesting. We now know this can't be a 6. So one of these is 2 or 3, and the other one has to be 4 or 5 for these specific cells. And so one of them has to be 2 or 3, which means one of them has to have a 1 as the digit. E is either 1 or S is either 1. So then the possibilities are 12, 1, 2, and 2, or 1 and 3 for E, S, and E. because this can never no longer be specifically 6 or 7, and this can't be 6 or 7. So one of them again has to be 2 or 3. So one of these, interesting. Huh. No, actually that doesn't, no, never mind. I was thinking that this had to be 2, 3, 2, 3, but that's only if SS is 11, right? Hmm. Okay. So this is 12. This is 12, 13, or 21 or 31. I'm not sure which. Um, you cannot have a 2, 3, 4, 5 in the rest of this Nabner line. Therefore, you have to have 1, 6, 7, 8, or 9 in these. Well, this can never be 9, because then that would eliminate all the cells. That would say this is one region, and this region could not expand. So this can't be 9. Actually, can it be 8, 6, or 7? If this is, I guess it could be 6. No, it can't be 6, because then this is part of a region, and region is blocked. Oh, right. So any region that's 6, 7, or 8 here. Ah. Any region that's 6, 7, or 8 here is blocked. Right? This will be a region if this is 6, 7, or 8. And it has to be part of a region with this then. If it's 6, 7, or 8. Therefore, this region would be blocked from extending out to become a 9-cell region. So this can never be 6, 7, or 8. Therefore, this is a 1. So this cannot be 1. This has to be 6, 7, or 8, 9. This must connect with one of these two regions. We're not sure which. Therefore, neither of these can be 2. So one of these has to be a 3, and obviously is 11. The other one has to be 5, actually, then. Interesting. So this is a boundary. We're going to mark it, I don't know. Black? Does black work? Is that seem... It seems too... It doesn't seem obvious enough. I'm going to make it red. Though that's kind of conflicts with the orange. Maybe green? Or maybe blue. Blue seems like it works okay. So this has to be a boundary. One of these is a boundary, and one of these is a boundary. One of them obviously is 11. One of them obviously is 11. So if SS is the 11, that means this would have to be 2 and this would be 3, which seems feasible. If EE is the 11, this would be 2 or 3, but this would be 5. So this can never be 5, and it can never be 3. If SS is not the 11, that means this has to be 5, which means this can't be 5. But if SS is the 11, it's 2 or 3, and it can't be 3, because that would be 3. Therefore, this cannot be 3 or 5. It's 2, 4, 6, or 7. This can't be 6 then. Oh, that's interesting. Oh, hold up. If This has to be at least 7. That's actually very interesting. That means this can never be 4. It could be 4, but it can never be 5 or more. So this is 5. This has to be specifically 2, 3, or 4. This has to be a different region than this. So we're going to make this pink, I guess. This actually could all be the same region. Could it? Yes, 1, 11, and 33 add up to the same region. So that actually could all be the same region. Huh. Interesting. If this is 7, 8, 9, 10. No, this cannot be 4. Okay, well, there you go. This has to be at least 7 because it can't be 6 because we know this has to be a Nabner line with 1, 3, and 5. Well, then this has to be 7 or greater. This cannot be part of that region because if it's 4, then this becomes a 10-sized region, which is not allowed. So this has to be the 2 or 3, which means this has to be 3, and this has to be 5. So we know this is specifically a region, and it could be part of this region. We're not sure. But we do know that the boundary is here, and this is a boundary, and this has to be a boundary because of it has to be 3 with 7, and that would add up to 10 again. So this is 2 at most. Sorry, at least. This is 2 or 3. This cannot be 2. So this is 2 or 3. This has to be 4, 6, or 7. If this were 5, adding up to... Well, okay, this can never be greater than 3 either, right? Because in this region, this would have to be one contiguous region, and that doesn't work. So this also can't be 2 or 3. Sorry, this also has to be 1, 2, or 3. It can't be greater than 3. Because then, again, this would be essentially a 10-size region if this is 4 or more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this has to be 1, 2, or 3, but it can't be 2 or 3 because of the Nabner rule. So therefore, this is a 1. This has to be 3 then. And therefore, this can't be 4. This has to be 6 or 7. Therefore, we know, since it's 6 or 7, it cannot add up to 22. It must add up to 33 specifically. So this is 33. And this has to be then 5, 4, 7, 8, 9. Right? Because that's the only 5-digit set, with including 5, that adds up to 33. Therefore, this can't be 7. This has to be 6, which makes this a 2, right? As the last remaining digit. This is 6. This is 2, and it has to connect to this one. So this has to specifically be part of this region, because this is... Oh, wait, no, this is not a... That doesn't have a sightline XM clue, so then never mind. That's wrong. So this can't be 2. So S is 30-something. So this is 33. S is 30, which means this cannot be 3 or 4. It has to be 5, 6, or 7. This is 31 specifically. And it cannot be part of this region. Therefore, this must be 5 specifically to be part of that region. So this is orange. This is 1. It's either 10 to 19. 19 could have 5 digits, but this can't be 5. It can't be 5, 6, or higher, though. So this is specifically 2, 3, or 4. This is 30-something. If it's part of that region, that would be too big. So this cannot be 7. So So, and it cannot be 3 or 4 because it's 30 something. Oh, it could be 30, but if it's 30 with 4, that would have to, that doesn't work because the 4 digits add up to 30 is 4, 6, 7, 8, 9. This is 6 digits adding up to 33. This is 3 digits adding up to this is 1, so this goes with either here. So say this 1 actually was only part of the 3. The problem is you could have at most, how many digits now are in this region? It's 15. And you can't have 2 regions full here. So if this is part of this cell, you can't have 2 regions because then that would be essentially right, so if this is part of this cell, okay, this is 3. We know this is, I'm going to make that green. This cannot be the same as this region because this is 6 and this is 3, right? It's obviously not part of this region. So it does block this off. If this is 1, how many digits can this add here, right? It could be 1, 2, 3, 4. It would have to add 5. So it could be 5, 6, 7, 8, 9. Oh, that is possible. Huh, okay. This cannot be, this has to be 7. This can't be 8 or 9. Right, so if this is not connected, this actually could go this way. This needs a 1 and a 1, 2, 3, and a 6. Obviously, it's not part of the same region here. So the 3 has to be, well, this could be part of the region, right? This could be 3, 2, 6. So this, again, could be part of the same region. Can they be different regions is the question. Well, this is a different region than this. 1, 2, 3, 4, 5, 6, 7, 8, 9. But then that would block this region. So if this is part of a region with this, okay, so okay, 1, 2, 3, 4. Okay, well, this can't be part of this region either. Aha, okay, so therefore, okay. Can this ever be separate from this region? No, the answer is no. Try to make one that does, right? So say it's actually part of this. It can't be part of this region, obviously. Can't be part of this region, so it has to specifically go here if that's the case. And that would block this off from being a full region. So this would, if this were not part of this region, it would have to be its own separate region. Here, because it cannot be here because it sees only 3 and this is not part of that region. Therefore, it has to go here, and that would block this from ever being a full region. So therefore, this has to be all part of the same region. Therefore, we know this is a region, and it's full. We have the full region now for this region. Therefore, this is 2 and 6 here to add up to 11. This, remember, has to be 31. And it's 5 digits adding up to 31. What does that require? Oh. That means the other 4 digits must add up to 26. Well, that could be 2789. It could be 3689. Oh wait, it needs a 5. Oh yeah, yeah, yeah. 226, 2789, 3689. It cannot be 4, right? Because that would have to be, well, maybe it could be 4. 2789, 3689. That means the other ones would add up to 22. So it could be 4679. Yeah, I think those are the only possibilities. And okay, so yeah, none of these can be 1. This can't be 1 because this can't be 1. This sees the 1 from here. So where's the 1 in row 3? It has to be here. So this is definitely 1. This can be either 2789 to add up to 31 completely, which would make this 6, this 4, and this would then be 3. Or this is 3689, in which case this is 2. So this would be this would still be 4. And this would be 2. This would be 7 then. And this would be sorry, this would be 4 or 7, and this would be 4 or 7. So that's possible also. Well, actually, hold up. Let's not go down this route yet. What do these two cells have to be? What set can these two cells be part of? It can't be a separate set from the gray or the green because that would only then be 6 cells. It cannot be part of the gray because that can only reach 2 in. Therefore, these must be part of green. So these are part of green, and this is part of green. This doesn't have... Actually, this one kind of has to. Right? It has to connect some way, and if it goes this way and this is not part of green, what region is it part of? It can't be part of any other region. So this has to be part of green. This has to be part of green to connect. Therefore, this can never be a 3. So where is the 3 then in this row? It has to be one of these cells. If that's the case, then this has to be 3, 6, 8, and 9, adding up to 31. Right? Because we know S is 3, we know E is 1. So to add up to 31, you need 3 and a 5, which adds up to 23. Sorry, that adds up to 8. And 31 minus 8 is 23. And there we have 3 digits, which must be 6, 8, and 9. So this can't be 8 or 9. This is then a 2. This has to be a 6. This is 4 or 7. We're not sure which. So this is of size 1, 2, 3, 4, 5, 6, 7. So we only have 2 more digits now. Let's see. Obviously, this could still connect here, and that would connect there. That would be fine. We know this is a boundary. We know, obviously, this is a boundary. This is obviously a boundary. This we don't know. We know this is a boundary. Oh, this is interesting. Huh. So either this is 1, and it's not part of this, or it has to be 3 or 4. right? Because this would be 6, 7, 8, and 9 potentially. So this is specifically 1, 3, or 4 here. We don't know which. This has to be 5 at least here. So we're going to make that yellow. What can this cell be? If this is red, the problem is that's actually very problematic, because if this is red, all of these cells would have to either be part of red or a separate region, but the separate region would be less than 9. So therefore, this would all have to be part of red, but then that would make this a 12 size red. So this cannot be red. It cannot be a separate region, so therefore it must be part of yellow. So this has to be 1. Um, what about the remaining cells here? This is 5 at least. So this could be 5, 6, 7, 8, 9. This is only 3 at most here that could be red. So all of these cells have to be yellow. And we know then this has to be at least red, because it can't be a separate region, and it can't be part of yellow. Similarly here, this can't be part of yellow, because this is the extent it could go to. So this is red, this is red. What? Well, this could be part of gray. This has to be red or yellow specifically, right? We don't know which. So we know specifically this is a border. Obviously, these are... We're gonna just encapsulate everything here. Is blue good? I don't know. Let's make it red. It's just easier to see, I think. Yeah. Okay. We know this is a border. This is a border. This is all a border. We also know this is a border here. Okay. Hmm. Hmm. Okay. What about this region? Well, if we try to make this orange and gray as a as not a full region, only 2 of these could be orange, and only 2 of these can be gray, and only 4 of these could be orange. So without a full region, this doesn't work. So therefore, this has to have a full region somewhere. Um, and only 1 digit can be not part of that full region. So therefore, these 4 are a full region by itself. This also has to be, what, 2, 4, 6, 8, 9. Any of these could be orange, and any of these could be gray. So unfortunately, that doesn't tell us very much. Um, we know there's no 1 in any of these cells. So the one in column 7 has to be one of these two cells. We're not sure which. How many extra digits cells do we have? So this is 7. This is 7. This is 8 already. So 7, 7, 8, which means we have 2, 2, and 1. 5 digits remaining. And these are specifically 5 digits, and they cannot be part of a separate region. Okay. Well, then, what does that mean? So again, this is 8. These all have to be red, green, or gray. And this only can take 2. This can only take 2, and this can only take 1, which is exactly the amount of cells that we have to distribute in these cells. So therefore, we require then the extra cell that this has in this region. So this can never be red. So this has to be yellow, which means this is the entire region for yellow. So it has to be here, which means this has to be here, which means this must be a 5. Let's see. This then has to be a boundary because it cannot extend any further here. Similarly, this isn't boundary, so this cannot extend any further. Therefore, this must be a dark gray. This must extend either 2 here, or it could be 1 here, 1 here. We don't know what. This is 11. So it's specifically then 1, 7, but this can't be 1, so this would be 7 and 1 if that were the case. It could be 2, 6, except that this can't be 2 or 6. And then another 11 is not possible. So then this has to be 7, which makes this a 1, which forces this to be 4. That's a 7. So this can't be 7s here. This is then 3, 7, 1, which means this is not part of that region, so it has to be part of red. So therefore, that is part of that region. And we don't know how this breaks down. So this is the boundary here. This adds up to 33, which means the rest have to add up to 12. Therefore, this is a 9. And this is the remainder of 3, 4, 5, 7, 8. This can't be 4, 7. This can't be 3. This can't be 7. 2 and 9 both have to be here. So this is 2 and 9, which means this can't be 2 or 9 in any of those cells. This is 30-something. We're not sure which. This has to be what? We have 3, 4, 6, 7, 8. This is 3, 4, 6, 7, 8 also. What are the remaining cells here? It's 2, 3, 5, 6, 8. 2, 3, 5, 6, 8. 2, 3, 5, 6, 8. 2, 3, 5, 6, 8. Well, these can't be 3. Aha. Well, that doesn't tell us much. This can't be 6. Because this is the same region as this. What about this? This can't be 3 or 6. So it's 4, 5, 7, 8, 9. 4, 5, 7, 8, 9. This is 4, 5, 7, 8, 9. This would be part of green or gray, which both have a 7. This would be part of green or gray, which both have a 7. This can't be 7. So this specifically has to be remaining... One of these two is a 7. We're not sure which. We do need a 9 in this green. So one of these four, sorry, one of these three cells must be a 9. But we're not sure which. Hmm. Um, this could be 5 this way and another 5 there. Oh, it cannot be 5 there. This can't be orange. Because if this were orange, the problem is we need one of these to be orange also to add up to 10. Because we have a 9 region here, and we need another one being orange. So therefore, this would only have 4 other digits, or 3 other digits it could have, which would be most 1, 2, 3. So this cannot be orange. It's its own separate region, pink. Similarly, this can't be orange, right? And it can't be any of the surrounding cells. If it tried to be a different region than the pink, the problem is... Oh, yeah. So this has to be its own separate region. And what's the most it could be? It has to have 9 at least. So therefore, all of these are pink. 1, 2, 3, 4, 5, 6, 7, 8, right? Now, it could be 9 here or 9 here, but we don't know. So this is orange or pink. This is, well, it could be the other one, which is blue, right? This region has to be, this orange can go down, it has to have 1 here, so it can only go down 3. So this is the most it could go down. This is the most it could go down. So the rest of them have to be blue. So this is 6 blues then. Which means this could go 3 here this way, or this could go 3 here that way. So then this is black or orange. This is green or gray, and this is green or gray. Right? Okay, so where are the boundaries we know then? We know this has to be a boundary. We don't know about anything else there. We don't know about anything else there. Okay. Well, let's see. We know this set of cells has to be 1, 3, 5, and 7. Because they have to have all the rest of the dark gray cells, which can only contain 1, 3, 5, and 7 because 2, 4, 6, 8, and 9 is in these 5 cells. So this can never be 1, 3, 5, or 7. So this can't be 5. This can't be 1, 3, 5, or 7. So this has to be 2, 4, 8, or 9 because it cannot be 6. This could be pink also, right? So this could be pink. So one of these two is a 1. Again, this is 30 something. Ugh. This can't. Oh, well, no, it still could be 3 because that could be part of gray. Hmm. This cannot contain a 1 or a 7. Well, what can this be then, as an Abner line? You can't have 1, so you have to have 1 out of 2 or 3, 1 out of 4 or 5, 1 out of 6 or 7, and 1 out of 8 or 9. Well, that means you have to have a 6. That means these are all have to be even, right? This can't be 1 and it can't be 7. So the only way you can have, you would have to have 2, 4, and 6 to get 3 unique digits, and one of 8 or 9 has to be. So we know this then cannot have a 3, cannot have a 5. Therefore, this is specifically 2, 4, 6, 8, or 9. Well, what are the remaining digits? So this can't be 2 or 4. This has to specifically be 8 or 9. Well, the remaining digits then are 3 and 5 here. Because we have a 2, 4, 6, 8, and 9 quintuplet in column 4. Therefore, the gray cell cannot have a 3 either. So this could not be 3 also. Where is the 3 in column 2? It has to be here. So this is a 3, which means these can't be 3. This has to be specifically 1, 2, and 9, but this can't be 1. So this is a 1 here in one of these two cells. 5. 5 can only appear once in these two cells. And okay, so 5 has to be in one of these 3 cells for green. And it's already in gray in the 3, 5 pair here. So this can never be a 5 in the rest of this column. That could be green or gray, because the green 5 has to be one of those 3 cells, and it cannot be here. The gray 5 has to be one of these 2 cells, so it can't be here. So therefore, this can't be 5, this can't be 5. We now have a 4, 8, and 9 triplet in column 3, which eliminates 4, 8, and 9 from the rest of the column. This can't be 4, 8, so this must be 7. This can't be 4, 8, or 7 now, which means this must be 5. So this can't be 5 here. This obviously can't be 7. We need then a 7 in one of these 4 sorry, this can't be 7 here. So a 7 has to be in one of these 4 cells. Well, this can't be 7, this can't be 7. The 7 can only be in one of these 2 cells. Therefore, it has to specifically be a 1, 7 pair then. Because those are the only 2 places in column 7 which can contain a 1 or 7. This then has to be 2. That doesn't really tell us much. This can't be 7. This has to add up to at least 30. Can it add up to 30 without an 8? Oh, actually, this can never be... This can't be more than 2, right? Because we know this is specifically pink, and this can never be pink. So then this has to be 2, and therefore this can't be pink, which means this has to be the pink. So this is orange. Well, only one of these is orange, so orange has to go down here, which means both of these then have to be orange. So these are the same one. And therefore this adds up to, well, can't add up to 11 because ours can never be a 1. And the most it could add up to then would be 10. So this has to be 2, 8. Whoa, that's not good. That's bad because this is the same region. We know this is 3, 6, 8, 9. Ooh, that's not good. This is 8, at least. Ooh. Shoot. That's not good. Shoot. Okay, that's a problem. Hmm. That's a real problem. It can't. This can't be 1, right? Yeah, because it's 10. That's 2-digit numbers, yeah. That's not good. That's really bad. Where did I break this is the question, right? Oh, wait. Okay. Yeah, yeah. Well, there you go. Yeah, okay. It's not that broken. It's not that broken. Right. I forgot about this. This doesn't have to be pink. So pink could extend here. Pink could extend here. So, okay, it has to go that way then. Okay, okay. Woof. That was bad. I was thinking, okay. Yeah, I forgot orange can extend further. Orange can extend 3 here. It cannot close this off, but this specifically has to be there. And therefore, we know then this has to be pink. Okay. Okay, whew, that was, so this could be 1, 2, 3, 4, 5, 6, 7, 8, 9 down here. This could be pink, but this can't be pink. Because that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 away from this pink. And we know this can't be 2 and orange. So if this were orange, this would have to be 2, but it would have to be 2 and 8 added together, which is not possible. So this is no longer orange possible for either of these. Therefore, this can't be orange either. Where can the orange be? It has to be 1 here, and it has to be all 3 oranges here. Whew. So this is orange. This connects this way. Well, this can't be blue either. Well, actually, it can't be blue either because then that would block off the pink. We know this is specifically pink. Therefore, this must be pink, and it has to be 4. So we have 1, 2, 3, 4, 5, 6, 7, 8 pinks. We now have 1 extra, which is one of these two, so this cannot be pink. This has to be blue. The rest of this is 1, 2, 4, or 7. But we're not sure which one. This can't be 4. This can't be 4, and this can't be 4. Well, we have an 8, 9, 8, 9 pair in row 4, which eliminates 8 and 9 from the rest of the row. So this can't be 8. This is 4 digits. It still could be 10, actually. This is 2 through 7. This is 2 through 7, but no 4, obviously. So this can't be 4. And this can't be 4. This can't be 1 or 7. So this is 2 or 4 here. We have an 8, 9. Okay, so this is... Could still be green. Ah, well, okay. We have a 4 in this green. Therefore, there is a 4 in one of these two, and it has to be then a gray, which means 4 cannot be in the gray here. So this can't be 4. We know there's a 2 here, and it could contain a 6, an 8, or a 9. So 4 has to be one of these two cells, but that doesn't really tell us much. We don't know how much. Okay, so can this ever add up to just 30? Well, let's see. We know we have 2 and 9 here, and you have 5. So that's 16. So the other two digits would have to add up to 6 and 8 for that to be 30. I guess it's possible. Then this would be 3 and this would be 4 if that's the case. Hmm. Uh, hmm. This is 2 and 9 specifically. Hmm. Okay, what's the orange digit here? It can't be 3, 6, 8, or 9. But this could be, again, 1, 3, 5, 7 for the grays. But this can't be 3 or 5. And it could be 1, 2, 4, or 7 for the orange. So we know 9 has to be one of these two cells. 8 has to be one of those 3. But that doesn't tell us much. This obviously can't be 4 or 5. So this is 1, 2, 3, or 7. The orange here cannot be 1 or 7. Right? Because if this is 1 of 7, the orange, we know the dark gray also has to have a 1 and a 7 in this row, which is not allowed. So the orange 1 and 7 has to not be here, which means it has to be in these cells. Well, it cannot be here, so where are the only two spaces that 1 and 7 can be? It has to be here. So this cannot be 2 or 4. This can't be 2 or 4. This specifically then has to be 1, 7. So this is not 1, 7. This can't be 7. We have a 4, 8, 4, 8 pair in row 8. Therefore, it eliminates 4 and 8 from the rest of the row. So this must be a 7, which means this can't be 7. Also, we have a 1, 7, 1, 7 pair in row 4, which eliminates 1 and 7 from the rest of the row. So this can't be 1 or 7 either. Interesting. This can't be 1 or 7, but it could still be a lot of things. 2, 3, 4, 5, 6, 8, 9, but no 4 actually. Um, hmm. Mm hmm. 1 or 7. This has to be 2, 3, 4, or 5. Hmm. Um. Oh, this can't be 2 or 4, right? This is 1 or 7. Oh, this can't be orange, right? If this is orange, yeah, we know the 1, 7 orange has to be those two cells. So this cannot be orange. This has to be dark, which means this is a boundary, but that doesn't tell us very much. So this could be, okay, so if this is 3 and 4 here, this does add up to 30. Oh, wait. Yeah, this is at least 8. This is at least 7. And we know this has to be 30 something, but this is 30. Therefore, this is the minimum here. So if this is 1, 7, this is 3, and if this is 4, that's the minimum amount you can have to add up to 15. Well, that means the maximum of this is 30. So we know then this R has to be a 0, because then this is 30. So therefore, this is 3, this is 4. It's not 6. This is 3, this is 4. Obviously, this can't be 3. These can't be 3. The rest of this must be 2, 6, 8, and 9. Because that adds up to 25. And then 25 plus 5 is 30. So this has to be 10, which means this has to be 1. This is 7, and this has to be 2 and 3. Well, we have a 2. This can't be 1 anymore, so this is 7, which makes this a 1. We have a 2, 3, 2, 3 pair in row 4, which eliminates 2 and 3 from the rest of the row. Therefore, this must be 5, and this has to be a 6. This is 3. So this can't be 6 here. Cannot be 6 here. Obviously, this can't be 7. This can't be 7. This can't be 6 or 8, because we have a 2, 6, 8, 9 quad in this region. So therefore, this has to be 4, which makes this a 3. This must be then an 8. This is a 4. This can't be 8 anymore, so that's a 9. This can't be 8 or 9 because of the 8, 9 pair. So this is 2 and 6 specifically as a pair. This has to be specifically 6 and 8 because that's all that's left in the row. 2, 3. This is 1, 2, 3, 4. So the rest of pink cannot contain 1, 2, 3, 4. Therefore, this is 5, 6, 7, 8, and 9. But this can't be 7. Now in pink, we have a 5, 6, 8, and 9 quadruple. We also have 1, 2, 3, 4 as a quadruple. Therefore, where is the 7? The 7 has to be one of these two cells. Let's see. This can't be 4 anymore, therefore this must be a 2. which means none of these cells can be a 4 because, or sorry, can be a 2 because we already have a 2 in the rest of the orange cells, and we have the 2 in the gray, dark gray cells. This can't be a 3 or 4 because of the 3 and 4 in the column, so this must be a 5. Well, this can't be 6 or 8 because of the Nabner rule set, so because of the 7s consecutive with both 6 and 8, therefore this must be 9, which means this can't be 9 and this can't be 9. This is a 5. The 5 cannot be part of orange, so it must be dark, which means that's a boundary. This can't be 9, and we know there's a 4 here. Where is the 2 also in column row 2? It has to specifically be here. So this is 2, and this has to be 8 because there's no other place for 8 in row 2. So this has to be 8, which makes that a 9, which makes that a 4. This can't be 4 anymore, therefore this is 8 and 9. We have an 8, 9, 8, 9 pair. This is 2 and 6. This can't be 2, so this is 6, which makes that 2. This can't be 2, and this can't be 2 because of the column. This can't be 8 or 9, so it must be a 4, which means this has to be a gray. Cannot be green. One of these 3 is an 8. We're not sure which. Okay, so this can't be 5 anymore. This can't be 5. These can't be 4. These can't be 4. This can't be 2 or 9. This can't be 5 or 9, so this is 6 or 8. This can't be 1. This cannot be, we have a 5, one of these is 5 or 9. We're not sure which. Well, two of these 3 are 5 or 9 because this can't be 5 or 9. Therefore, this can't be, the rest of the column cannot contain a 5 or a 9, so this can't be 9. This can't be 2 or 6. This can't be 6. This can't be 2. The remaining digits here are 3, 5, 6, 8, and 9. This can't be 7 also. So this is where, okay. Okay, yeah, we have a 5, 6, 8, 9 quad in row 7. So therefore the rest of the row cannot contain 5, 6, 8, and 9. So this must be 3 and 7 specifically. This has to be, there has to be a 4 in one of these in row 6, and it can't be here, so this must be a 4. And this must be 5, 8, or 9. And it can't be 5. We have an 8, 9, 8, 9 pair now in row 6, which eliminates 8 and 9 from the rest of the row, so this must be a 5. This can't be 5, and this can't be 5. We have a 6, 8, 9 triplet in column 6, which eliminates 6, 8, and 9 from the rest of the columns. Therefore, this can't be 6, 8, or 9. So this must be 2, which makes that a 3, which makes that 4, which makes that 2. So this can't be 2 anymore. This can't be, none of these can be 2. So this cannot be part of gray. It has to be part of orange. So the rest are part of gray, sorry. So we have those cells now. So this is the boundary for the orange and the dark. Okay, this can't be 9 anymore, so this is 8. This can't be 8, so this is 9, and it cannot be part of dark. Therefore, this is, sorry, medium. So it has to be part of green. Well, This can't be 9 anymore. This can't be 9 anymore. That means we have a 6, 8, 6, 8 pair in column 6, which means this can't, the rest of the cells can't be in column 6, can't be 6 or 8, so this must be 9, which means this can't be 9. What are these cells? It has to be 2, 5, 6, 7, 8. This can't be 2, and this can't be 5. 6 and 8 are not allowed in either of these cells because we already have a 6-8 pair in pink and in blue. So 6 and 8 cannot be here. So it's either 2, 7 or it's 5, 7. And this can't be 4. Okay. We have a 6-8, 6-8 pair in column 7, which eliminates 6 and 8 from the rest of the column. Therefore, this must be a 5, which makes this an 8. This can no longer be gray because we already have a 5 that's in gray. So this has to be green. This can't be green then. This has to be gray. So we can draw that boundary. Now what are we missing? 6, 8, 6, 8, 6, 8, 6, 8. Let's label them A and B. So this is A, which makes this B. This also has to be B, and this has to be B. Since this is B, this has to be A, which makes that B. A has to be one of these two. We're not sure which. This can't be B, so this must be A, which makes that a B. So A has to be one of these two. B, we have all of them. And A cannot be here because it's the same set. Well, where can it be? It has to be here, right? Because it's one of these two, and it can't be this one. So this has to be A, which means this cannot be 9. Therefore, where is the 9 then in row 1? It has to be here. So this is a 9, which forces this to be 1, which makes that a 3, which makes that a 1. This can no longer be 3, so this is 7, which makes that 3. This can't be 7, so this is 5, which makes that a 7. Oh, this can't be 8 anyways. This is 6 or 8, but it can't be 8, so this must be a 6. Okay, yeah. So all the B's are 6s then, which makes that a 2, which makes that 9, which makes that a 2. And all the A's must be 8. So this is 8, this is an 8. This can't be 9, so this is 8, and we know this boundary cannot, whoops. This boundary goes like this. So this is not pink, this is blue, and this is not blue. And this is the last 9. So that's the puzzle. You solved the puzzle, the solution is correct. Yay! I love chaos construction. It's just a very interesting way of solving a puzzle. Yeah, throughout this was always kind of I made one bad assumption, which was this part, which was that this all had to be pink. But fortunately, this clue forced me to basically recognize that. Anyways, that is the solve, and I hope you enjoyed it. And I'll see you next time on Frank Puzzles. Take care.